Hello children, welcome to channel Sube. Children, today I am going to discuss question number 16 from the MCQ part of 2022-23 Physics new syllabus paper. Which of the following can store one bit of data? First one AND gate, second one NOR gate, third one XOR gate, fourth one OR gate, fifth one flip-flop. So children, the answer for this one is flip-flop, because regarding an AND gate, you can't store data, store a bit, because when you put off the switch, the output will be changed. So it is like this. Children, suppose we have an AND gate like this, and we have arranged the circuit like this. We have placed the 5-volt battery here as the power source. So inputs are arranged like this. Already we have given one of the inputs of this AND gate, logic 1. You can see from this resistor the ground is connected and the positive side is connected from the battery directly. So here the logic level is 1 gate, one logic level. Logic level is 1. So here the line is not connected, so there is a switch. So therefore here the input is 0. So the output, we have placed a LED and a series and a 100 ohm resistor series with this LED to protect the LED. So the circuit is like this. Since this one of these input is 0 and the other one is 1, so according to the inputs, now what is the output? It is 0. It is 0, you know. Therefore this LED is off. So if we press this button, what happens? The line connector, the input gets 1 from this 5-volt battery. You can see 1. So both the inputs are 1. Now what happens? The output will be 1. So therefore this LED will be on. LED will be on. But if we return this switch back like this, what happens? This one goes to 0. The output will be 0. The output will be 0. This one will be 0. This one also will be 0. LED will be off. So this is the condition regarding an AND gate. But now I am going to show you the flip-flop. The flip-flop. Here when we return the switch backwards so that the input opens, what happens? The output changes. But in the flip-flop, the output doesn't change even though we return the switch backwards. The output stays as it is. So that is why we say it is a memory. So let us now go to the flip-flop circuit. So children, here I have arranged an animation for you. The real flip-flop, you can see, I have given the link in this video. In the description also there is the link, and also at the first comment I have entered the link of the real flip-flop that I had made. I uploaded that video a long time ago, so you can go to that video and see for yourself the real flip-flop, electronic flip-flop using transistors and resistors. So that is the real flip-flops. So here I am showing you the animation. Here I am showing you an animation. You can see both now. So let us run this animation. So the circuit is like this. I have neglected the transistors and resistors. I haven't included those electronic components here. just I am going to show you the function of this what we call flip-flop. So here there is a 5-volt battery as the power source. So there is a main switch through which the current passes to the circuit. This one is the flip-flop. So the flip-flop mainly contains 2 LEDs and 2 switches. 2 switches means these are tap keys. That means when we take our hand out of the key, out of the switch goes to off state. The switch goes to off state because there is a spring here. I haven't included that also. That means there is a spring here like that. Spring here like that. When you take out your hand, when you take your hand off the switch jumps back to off condition. Off condition. You can keep on condition only until you keep pressing this button, like a doorbell. You know the doorbell at the front door. We place a doorbell like this. So when press the doorbell, the bell rings, but when we take our hand out, finger out, it goes to the off condition. But this switch is not something like that. This one stays at on condition even though we took our hand off. So like it should be actually, this main switch should be actually like this. It is a plug key. This one is a plug key. So it is something like this. The symbol is, yeah, you see. So when we turn it to the on condition, on state, it stays at on state even though we took our hand away. But this switch is different. This switch is a tap switch. Only it stays at on state when we keep pressing it. Then only it stays at on state. Otherwise, if we took our hand away, it automatically goes to the off state because of this spring. So now we are going to run this. I explained about these switches. So let us supply power like this. Right, now we supplied power 5 volt. You see what happened. This LED became on. This one stays at off state. That is happening according to the non-equality of the transistors used. Even though we used the same numbers of transistors, there are little differences. So they are different actually, very little amount. So due to that, even though we used the same numbers, same transistors, there are 2 transistors. So due to the little manufacturing differences, one of those transistors become conduct before the other one. So if one transistor is conducting, the other automatically offs according to the structure of the circuit. So I am not going to discuss the circuit. I am going to only discuss the function. So now you see what happened when we at the moment when we supplied the power to the circuit, automatically one of these LEDs become on state. So we can't say which one practically we should do it. So if we identified that this one is the LED that became on as soon as we supplied power, we label it as S. We label it as S. That means set. That means set. So other one which is off as soon as we supplied power, so it is named as capital R. That means reset LED and set LED. So that is how we have to label them. So practically we should supply current, then only we can label them after looking at which one became on first. So now let us press one of the signal switches. So these are the signal switches as we discussed in the AND gate. So these are signal switches, this one, and here I haven't placed the switch here. So if I place the switch here, this one is going to be the signal switch. This one is going to be the signal switch like this. There should be signal switches. I used only one for convenience. So now we are going to press this. So watch what happens. What happened? The state changed. That means the circuit became reset. Circuit is now reset. So therefore we call this switch the reset switch. We call this switch, we label it like this. The other switch we label as set switch. So this one is the reset switch because we use this one to reset the circuit. We use this one to set the circuit. So now let us see what happens next. When we press the reset switch again, what happens? Nothing. So notice that even though we take out the finger from the switch is at off state, but this LED doesn't, the state of this LED doesn't change. So even though we press the switch again and again, reset switch, nothing happens. Now what we have to do, we have to use the set switch. If we are going to use any switch, now what we have to use is only the S switch, set switch. As soon as we press the set switch, what happens? The state of the LED is changed. So now the set LED is at in on condition, on state. Now watch what happens when we take our finger out the switch, off the switch. When the switch is off, the condition doesn't change. That is the main thing. Here again you can see here, now the switch is off, but the state of the set LED doesn't change. It stays as it is, as it was. It stays as it was. So again we can press, but nothing happens. So this is the function of a flip-flop. So if we do something, now what we have to do, only reset. Already the LED is at set state, even though we pressed again and again the set switch, nothing happens. The memory is this one. This one represents logic 1. This one represents logic 0. So as soon as until we supply this power, this condition 0 1 condition stays. So that is why we say this one is a memory. Even though we took our hand out, took our finger out of the switches are at off states, but the condition doesn't, the state of this LEDs doesn't change. What we did, we reset. We did reset the circuit. Now the circuit is at reset mode. So this is what flip-flop. So if you want to watch the real flip-flop using electronics, I have made it. I have placed the link in the first comment and also at the description. You can go to the video and watch it. So now children, it is obvious, the answer is this one. So children, what is this word bit? So we observed this circuit flip-flop. So there are two LEDs, two terminals. One is called reset, the other is called S. So out of these two terminals, two outputs, these are outputs, we consider only this set output. We don't consider this one, we neglect this reset one. So we consider only this LED S. So it has two, it can take two possibilities. There are two possibilities. Either S can take the value 0 or either it can take value 1. So again watch. So now S is 1, S is 1, that means it is on. Now it is off, this one is off. If we press the reset button, again we can go to set. Now again S is 1. So like that, either it can be 0 or it can be 1. So we if we make 8 circuits like this, 8 flip-flops like this total one I write as like this, total circuit. So there are, if we make 8 circuits like this, 8 flip-flops like this, it is going to be a byte. It is going to be a byte. So this total thing is called byte, 1 byte. This single one is called a bit. So it can be either 0 or 1. All these things can be controlled by those two switches. This by using these two switches you can control. You can give 1 or 0 to this output S. So therefore we can give this one 1, we can give this one 0, we can give this one 1, we can give this one 0. So I am going to generate this code 1 0 1 0 0 0 1 1, then 1 0 0 1 1. So if the bit pattern is like this, so we need 8 circuits. So this one represents the character A. So that is called, this one is called, the pattern is called ASCII pattern, ASCII code. So you know, I think these things. So that is why we call this one is a bit. So it is a memory. It can store data. It can store data because the state doesn't change until you supply the current. But this regarding AND gates, even though you supplied current to the circuit, the current supply is not this one. These are the signal terminals. You have to use additional wires to supply current here. These are the current wires. Normally we don't show in block diagrams. The current wires are there. Even though you supplied current to the AND gate, if you put the switch off, what happens? It goes to the previous, or not previous, to the condition, to the state that is given by the truth table. According to the truth table, it takes a value, certain value, if you put off this switch. But here, even though, so you watched it, even though you put off the switch like this, it doesn't change. It doesn't change. Only at the first time it changes. After that it doesn't change. So that is why we say it is a it can store data. So that is a memory. So I think you understood this. So children, what I showed you is only an animation, but I have uploaded the real video using transistors and resistors, the real flip-flop. So it is very hard to find out in YouTube. All the teachers do teach on the blackboard, not the real circuit. I had made the real circuit and I videoed it and uploaded a long time ago. So I you can get the link at the description. and also at the first comment box I have placed the link of that video, so you can go to that video and watch it, and you can understand easily the real flip-flop. So children, I think you are happy, so you have to make me happy too by subscribing my channel. If you still haven't done it, you can press the bell icon, and also you can press the thumb up icon, and you can share my link among your friends. That is how you can return me. So children, thank you very much for watching my videos, and thank you very much for subscribing my channel. So see you tomorrow at 6 o'clock in the evening. Goodbye children.